Okay, here we are back for part 2 of lab. So let's write some things on the board. First thing we're going to write is the volume of a cylinder is pi r squared h, correct? But what we have is, we have diameter, right? So we're going to have to write instead here, you're going to say diameter in half, correct? Then we know that pi r squared h, correct? Yes? Now we know divided by pi r squared equals h, correct? We know that, yes? We also know the volume of the P was what?
The volume of the P?
The volume of the P's. 0.0, right?
Yeah.
Is that right?
Yeah.
Okay, and what was the diameter of the...
0.65.
No, that was the height of the P, right? What was the... Wasn't it 9.50, right? 9.50 centimeters. This is cubic centimeters. Are we all right? Are we ready to rock and roll here? Yes or no?
Yeah.
All right. Excuse me while I get this. Okay. All right. So, how we doing? You getting this? Pretty straightforward. Now we're going to manipulate this data. This is called data reduction. We're reducing the data to something usable. Correct? And we're going to use everything we've been learning in chapter 3. Correct? Okay. So, what is the diameter? Let's use this equation, right? What's the volume? 42.0. How many significant figures there?
100.
How many significant figures?
Oh,
3 significant figures. Good. Yes? You with me? Now, what's the value for pi that we use? 3.14. Does that contribute to the number of significant figures? Can you see that? Does that come off that red? Can you see that on the video? Is it? You see it? Okay.
Yeah, to move a bit.
What happens?
No, so you can see it.
What's going on? Yeah, okay, I see what you're saying. Okay. So then what's the diameter is, what's half of 9.5?
Wait, why are we using that diameter?
That's the diameter of the little sphere. Didn't we do a circle on the,
Why are we using that one?
well, doesn't it have a height? Isn't the height of that cylinder, isn't the height of that cylinder the height of the beam? The height of the P?
Yeah.
So what we're doing is, we're going to find the height of the P, because this is the thickness, isn't it?
No, we're finding the height of the P?
Yeah, that's the whole idea. We're trying to find the height, the thickness of that P indirectly. We directly measured it. Now we're indirectly measuring it. Correct? Yes, you with me?
Yes.
Okay. So, what is half of 9.5? 4.75. So 4.75 centimeters squared. Okay? I'll rewrite this. 3.14. I'll rewrite this. 42.0 cubic centimeters. You see how many significant figures here? 3. How many here? 3. Why 3 here? Well, I'm just taking half of that. It's kind of a conversion. You maintain the number of significant figures, correct? So 3 divided by 3, how many are going to be in my answer?
1, 3. Oh,
3. Where'd you get 1 from? Just curious.
3 divided by 3.
He was my videographer. I'm not sure where that came from. That's okay. That's all right. You got like something in your eye or something. You made it. Yeah, exactly. Understood. Okay. So what is 42 get out your calculators. Yes? 42 divided by 3.1, parentheses, 3.1, 4 times 4.75 squared, end parentheses, equals. What did you get?
2.81.
I'm not sure that's correct. I hope that's not correct. Yeah, do you know how to use a calculator? Put the you want to play, calculate along with me. Okay, you go 42.0 divided by, open parentheses, 3.14 times 4.75 squared, close parentheses, equals. What'd you get?
0.592.
What'd you get?
83.
Okay. What'd you get, Anna?
0.59.
All right, so we have a verification. You always need to verify, okay? So you got 0.59, what? 28. Okay, now, what would the answer be?
593.
What would the answer be?
593.
2.593. I have 3 here and 3 here. I must have 3 in my answer. That's going to round that up, and the answer is going to equal, can you see this on the film? 0.593 centimeters. Correct? Yes or no?
Why is it 3?
Because the 8 is rounding the 2 up, right? That 8 is like looming over, right? Get it? You all right with that? Okay? So, the indirect is going to equal what? Is going to equal 0.593 centimeters, and the direct measurement is going to equal what was it? 6. What did we say? 0.65. All right, easy. Okay, now let's erase some of this and we'll do the error. Okay, can I erase this?
Not the red.
Okay, you got to hustle. Just remember, this is going to be on the video, so, right? Okay, we got to move. Okay, I'm going to erase this stuff. Okay. All right, now, how do you find error? Error equals the accepted value, the absolute value of the accepted minus observed. What would be the accepted value in this particular experiment? What's the goal? What's the standard that I'm measuring directly? Well, I'm giving it away, but wouldn't it be 0.65? That's the direct measurement, so that would be the accepted value, correct? All right, so it's going to be the error is going to be equal to the 0.65 minus 0.593, and that will equal the error. What is 0.65 minus 0.593? You can do it.
0.057.
You may want to put it in a calculator. Haley, you all right? 0.057?
0.057.
Thank you. Nice assist. 0.57. Okay. Is that the answer? That's not finished yet. What would the actual answer be?
Divided.
The error. What's the error? If you reported the error given the information as 0.057, I would give you no credit whatsoever. It's going to be It's going to be 0.06. Correct? Centimeters. The centimeters don't cancel, do they? Right? Why 0.06? When adding and subtracting, your answer must have the same precision as the precision of the least precise value. The precision here is 0.01. This is 0.001. Right? So it's got to have the precision of hundredth place, right? That's a higher precision, isn't it? Right? You get that? Okay, now, how do you find the percent error? Percent error will be the accepted value, the error will be the error divided by the accepted value times 100. What's the error? 0.06 divided by, what is it? Point what? 65 times 100. Yeah, times 100. What's the answer? What is 0.06 divided by 0.65? What is it? Times 100. You can do it. Okay, you can do it. 9.23 would be the math. Is that, do we have a verification on that, Anna? 9.23. So how many significant figures can I have in my answer? 3. I know, it's just a bad day all around, isn't it? That's all right. That's all right. In order to use logic, it is required that you are wrong. Okay, so that's okay. Okay, so it's going to be 9% error. Yes? In my last class, I think we got 5%. So not bad really altogether, is it? I mean, if I could promise you in every test that you're going to take from now till you stop going to school that you'll get a 91 in everything, how many people would kind of like that? Yeah, that's, half the class doesn't, but yeah, 91, I would take that and bring that to the bank, man. Yeah? Yes? Yeah. So if you're 9% wrong, you're 91% right, correct? Yeah. So, not bad for kind of a weird thing, is it? Yes?
When counting the significant figures, the 100% counts.
No, 100 does not count because that's just a conversion. I'm converting a decimal to percentage. That's not that doesn't enter into significant figures. Doesn't enter into it. Yes?
The error would be in the size of one piece.
There's a lot of error. It would be in the shape of the circle. It would be, it would be a variety of things.
Is that 1p inside?
Yeah, I have 1p inside. Ooh. Yep, could be. So there's a lot of error. There's systematic error. The systematic error is the ruler. It's not a very expensive ruler. I'm kind of forming the circle myself. A little weird. So the system, in other words, the procedure. But the point in the lab is to demonstrate just, we do indirect and direct measurements all the time. All the time. But why are we doing this lab now? Because of reading scales, accuracy, precision. Clear? Error analysis, the whole bit. Yes? The next topic after this, you mean like general topic, like next chapter? The next chapter will be chapter 4 on atomic structure, which is pretty straightforward. I know that Mr. Nair went over it with you. I know you had it in 7th grade or 8th grade. So I'm going to go through it very quickly. 2 weeks, tops. Yeah, it's reading, you know. Who discovered the electron? Anybody remember from Mr. Nair's class? When we think of the discoverer of the electron, who do we think of? The cathode ray tube. Who do you think of? J.J. You'll recall it quickly enough. Thompson. Yeah. Okay? End of part 2. Clear? Okay.